In this video, I am going to discuss viva questions about torsional pendulum experiments. For any experiments, the first expected questions are aim of the experiment, apparatus, and then formula. So for this experiment also, first we are going to discuss about aim of the experiment to determine the rigidity modulus of the material of the given wire by using torsional pendulum setup. So here we are going to find out the rigidity modulus. We are going to find out the rigidity modulus of the given wire by making the setup of torsional pendulum. Okay, this is the aim of the experiment. And the next one is apparatus required for this experiment. Let us see the first one, torsional pendulum setup. So what is the torsional pendulum setup? Let me draw this. So here one rigid clamp will be there which is attached with the wall. Okay, so this is the rigid clamp. With this rigid clamp only we have to suspend the circular disc by means of a thin wire. Okay, so the circular disc is suspended by means of this thin wire. For this thin wire only we are going to find the rigidity modulus. So this is the circular disc. This is the circular disc which is made up of metals. Okay, so here in both the end of this thin wire we will have the chuck nuts. So this is called chuck nut. Two nuts will be there, here one and here two. Okay, so two chuck nuts. The whole setup is called the torsional pendulum setup. So here already I mentioned a circular metal disc suspended by a thin wire. Circular metal disc suspended by a thin wire, rigid clamp and chuck nut. Rigid clamp and chuck nut. So the whole setup is called torsional pendulum setup. Apart from this, we need stop clock, meter scale, screw gauge, vernier caliper, and finally rough balance. So these are the apparatus required to perform this experiment, right? Next we are going to discuss about formula required for this experiment. The rigidity modulus of the wire is given by eta is equal to, actually this symbol is written like this. Okay, so it should be pronounced as eta. Eta is equal to 4 pi m r square by a power 4 into L by t square. Dynes per centimeter square is the unit for this. Okay, so this is the formula required for this experiment. Let me explain what are the terms present in it and its unit also. First one is m. M is the mass of the circular disc. Already I said we are going to use one circular disc. For this we have to find the mass in grams. Okay, so by using the rough balance we have to find out the mass of the circular disc. Next one is R. R is the radius of the circular disc which is measured in centimeter. By using the vernier caliper we have to measure this R. So to find the radius of the circular disc, right? And the next one is L. L is the length of the suspension wire in centimeter. So this is the wire. For this we have to find the length by using the meter scale which is measured in centimeter. And the next one is A. A is the radius of the suspension wire in centimeter. For this thin wire we have to find the radius. By using the screw gauge we have to find out this radius of the thin wire in centimeter. And finally T is the time period in second. Okay, so by using the stop clock we have to measure the time period. So what is meant by time period? Time period is nothing but the time taken for one full oscillation. Time taken to complete one full oscillation is called time period, which is measured in second by using the stop clock. So this is the formula required for this experiment. And here I mentioned the unit also. So this is in centimeter I mentioned. So in CGS, the unit is dynes per centimeter. Dynes per centimeter square. CGS means centimeter gram second. So everything I mentioned centimeter gram and second. So that CGS. In MKS or SI. MKS or SI unit also we can use. For that the unit will be Newton per meter square or Pascal. Newton per meter square or Pascal. Okay, in both the form we can mention, but in our experiment we are going to follow the CGS unit, dynes per centimeter square. So in viva they will ask what is the MKS unit for rigidity modulus, means immediately you should say MKS means meter kilogram second. Okay, so Newton per meter square or Pascal. This is the units required for this experiment, right? Next question is, what is meant by stress? What is stress? So in mechanics, stress is defined as force applied per unit area. So take one material. For this material, if you apply the force, okay, applying force per unit area, then it is called stress. Stress is also nothing but force only, but for the particular place we are going to mention. So force applied per unit area is called stress. So stress is represented as sigma. Sigma is equal to force by area. Force applied per unit area. This is the formula required for this. And sigma is the stress applied. So F is the force applied and A is the area of force application. Okay, the unit of the stress is Newton per meter square. For force Newton, for area meter square, so that easily we can mention it as Newton per meter square. There are two types of stress we are having. Let us discuss one by one. The first stress is called tensile stress. First one is called tensile stress and the second one is called compressive stress. Now see, first we are going to discuss about tensile stress. Stress is force per unit area only, but the force how we are going to apply. So take one material, okay, this is the material. I am going to apply the force, okay, in this direction. I am going to apply the force on both the ends of the material. So what will happen? The material gets elongated. That means the size of the length of this material is increased. So if the length is increased or area is increased, then that type of stress is called tensile stress. Okay. During the tensile stress, the objects will become thinner as well as longer. By seeing the diagram itself you can understand. So it will be comparatively thin as well as long. Okay, so that is the reason tensile stress means the force applied per unit area which results in the increase in length or area. Anything we can say, increase in length or area. So during that tensile stress, the objects gets a thinner and longer. So this is what you have to understand. And the next one is compressive stress. What is compressive stress? The same thing, but the force will be applied towards the object. So the force applied per unit area which results in decrease in length. So what will happen? The material's length will be decreased. Okay, either length or area will be decreased. So due to that compressive stress, the material gets thicker as well as shorter. Thicker as well as shorter. So this stress is called compressive stress. So I hope you understand what is tensile stress and what is compressive stress. So here length is increased, so it becomes thin and long. Here the length is decreased and it becomes thick and shorter. So that will be the difference between tensile and compressive stress. So now you will have the idea about stress and its types. Next one is, what is strain? So strain is nothing but if you apply the force, some deformation taking place. Now you see, by applying the force, the material gets thin and longer. So the deformation, how much it changed because of the application of the stress, that is known as strain. Okay. So strain is defined as the amount of deformation experienced by the body in the direction of force applied divided by initial dimension of the body. Okay. So now you see, already the length of object is L. After that it is changed into DL or delta L. Okay, delta L. So the length is changed. So how can we find it? The strain epsilon is equal to delta L divided by L. What is that? The amount of deformation after the stress, okay, divided by the original length. Original, that is initial dimension of the body. So that is called strain. Okay, first one is how much it is changed, okay, divided by the original dimension of the body. So this is strain is equal to delta L by L. Epsilon here is the strain due to stress applied, okay, and delta is change in the length and L is the original length of the material. And here both are the same thing, that means centimeter only we will mention, centimeter by centimeter. So both will cancel. For this strain there is no unit, that you have to remember for viva question. There is no unit for the strain, right? And the next one is, the strain is a dimensionless quantity as it defines the relative change in shape. right? And next, depending upon the stress application, the strain is also of two types. The same thing, if we apply the tensile stress, the resultant will be tensile strain. If we apply the compressive stress, the resultant will be compressive strain. So what is tensile strain? It is the change in length of your body due to the application of tensile stress, okay? And it is the change in length of your body due to the application of compressive strain. So depends upon the stress, the resultant will be there, okay? That you have to remember. So now we completed what is meant by stress and strain, right? So next we are going to discuss about Hooke's law. What is meant by Hooke's law? So Hooke's law states that the strain of the material is proportional to the applied stress within the elastic limit of the material. So this is very important, within the elastic limit. Once it crosses the limit, the stress will not be proportional to strain. Okay, what he is trying to say is stress is directly proportional to strain. How much stress you are applying, that much strain will be created. So that is what Hooke states. Okay, Hooke's law states that the strain of the material is proportional to the applied stress within the elastic limit of the material. So stress is directly proportional to the strain. So if you take like this, stress by strain, which should be equal to constant. That constant is nothing but modulus. That constant is nothing but modulus. So this is what we are going to discuss. So stress by strain is equal to modulus, which is given by Hooke's law. Okay. So next one is, what are the types of modulus we are having? There are three types of elastic modulus. Okay. First one is Young's modulus. Second one is rigidity modulus or shear modulus, and then bulk modulus. So for our experiment, rigidity modulus is the aim. Okay. So we are going to understand what is the rigidity modulus, what is the formula for that. Let us discuss one by one. First one is Young's modulus. So what is Young's modulus? Here the Young's modulus is equal to, that is the ratio of tensile stress to the tensile strain, or compressive stress to the compressive strain. That's it. Okay, for example, tensile stress to tensile strain, or the same way we can say compressive stress to compressive strain. So this is called Young's modulus. So when a wire is stretched or compressed, the ratio between tensile stress and the tensile strain is defined as Young's modulus. So what is the unit for the Young's modulus? Now you see, for the stress we have the unit of Newton per meter square. For strain there is no unit. So the Young's modulus unit is Newton per meter square or Pascal. Okay, the same unit as that of stress, right? And next one is bulk modulus. What is the bulk modulus? Modulus means stress by strain, but which stress or strain we have to consider. So bulk modulus is defined as the ratio of volume stress to the volume strain. That will be the difference. Here tensile or compressive, and here it is volume stress to the volume strain. Third one is our important modulus, that is rigidity modulus or shear modulus. Rigidity modulus is also known as shear modulus. The rigidity modulus is defined as the ratio of shearing stress to the shearing strain. Okay, shearing stress to the shearing strain. Okay, so by using this rigidity modulus, we can able to twist the wire. So this is the wire, means we can twist it. Okay, so if the value of the rigidity modulus is very small, so very easily we can twist the material. That is what we have to understand, right? So these are the three types of modulus available. So first one, Young's modulus, is equal to tensile or compressive stress to tensile or compressive strain. Okay, and bulk modulus means volume stress to volume strain, and rigidity modulus means shearing stress to shearing strain. So this is very important for the viva question. Okay, and the next one is torque. Question is, what is torque? Okay, so here our experiment is torsional pendulum. To understand the torsion, first we should know about what is meant by torque. So torque is the measure of the force that can cause an object to rotate about an axis. Okay, so now you see in this experiment also, this is the thin wire and this is the circular disc. By using the circular disc, we are trying to rotate this object about an axis. Okay, this is the axis. Okay, about this axis the oscillation takes place. Listen carefully, about the axis, this is the axis, about the axis the object is moving, right? Rotating. So this is called torque. Torque is the measure of the force that can cause an object to rotate about an axis. Okay. So this is what we have to understand. So torque is also one type of force only, but that force makes the object to rotate about an axis. Okay. For example, you take the wheel, bicycle wheel is there, no? Bicycle wheel, how it will be about the axis, it is rotating, okay, about the axis. So this is one example for the torque, right? And then even steering wheel of any vehicle also about the axis, the vehicle, that means the steering wheel will move this direction and this direction, so that we can able to operate the steering wheel. So that is also the example for torque. Okay, about the axis, if any object is rotating, then it is called torque, right? Generally force means what? Actually either push or pull, right? Force means what? Push or pull. So the object will move in linear direction only, either left or right or up or down, only linear direction. But this is angular direction, that will be the difference. Okay, here linear, here angular. So force is what causes an object to accelerate in linear kinematics. The movement will be in linear direction. Okay. Similarly, torque is what causes an angular acceleration. So it is making the object to rotate. Okay, that's what it is called, angular acceleration. So hence torque can be defined as rotational equivalent of linear force. This we have to understand clearly. Torque can be defined as rotational equivalent of linear force. So what is meant by axis of rotation? The point where the object rotates. So about this axis, about this point, okay, that point is called the axis of rotation. The point where the object rotates is called the axis of rotation. So simply for understanding in physics, torque is the tendency of your force to turn or twist. If we are trying to twist the object, we will apply the force. That force is called the torque. Okay, so the unit of the torque is Newton meter. The unit of the torque is Newton meter. So for a viva question, you have to answer torque is the measure of the force that can cause an object to rotate about an axis. Right? Next, we are going to discuss applications of torque. So what are the applications in day-to-day life? We can say in any object experience torque, there is a pivot point about the center point. Okay, the movement will be there. Some applications are provided below. So what are the applications? Seesaws and wrenches. So seesaw means about the center, it will move up and down. Okay, it will like this, opposite direction about the axis. So that's what seesaw. And a gyroscope, pendulum or a parachute is applying torque when swinging. Okay, and a person riding a bicycle. And next, a flag flying on the mast. Okay, flag means about the axis, it will, okay, like this it will fly. So these are the examples for the torque, right? So you may ask how the torque will differ from force. So torque is a counterpart of force in rotational mechanics. Already we have discussed. So torque is the rotational equivalent, okay, of the linear force is called torque. The basic difference between them is that torque is the ability of a force to produce a twist around an axis. To produce the twist, to make the twist of the object, we have to apply the torque, right? And next, some examples of torque in everyday life. Already I said one is the steering wheel of any vehicle and another one is opening a bottle cap. For example, this is the bottle cap, means how can we apply the force? In both the direction we will apply. Okay, about the axis we have to apply the force. You just make it note on this. So opening a bottle cap or a turning a steering wheel are the examples of the torque in everyday life. Next, what is torsion? So we are using the torsional pendulum. So first we should know what is meant by torsion. In the field of solid mechanics, torsion is the twisting of an object due to the applied torque. The result of torque is torsion. Listen carefully. The result of torque, we are applying the force in angular direction. So one result is arrived. Which result? The object is twisted. That is called the torsion. So torsion is the twisting of an object due to the applied torque. Okay, so it is mentioned in Pascal. Its SI unit is Newton per meter square. Okay, the same unit. And next we are going to discuss about inertia and the moment of inertia, which is very important for this experiment. So inertia, what is meant by inertia? So inertia means inertia is the resistance to accelerate. Okay, so if you apply the force, immediately the material will not react for that. Some resistance will be present in it. That is called inertia. So inertia is the resistance to accelerate. Resistance to accelerate. This is happening in linear direction. If the same thing happens in the angular direction, then it is called moment of inertia. Listen carefully. Moment of inertia is the resistance to angular acceleration. The same thing. For example, force means linear and torque means angular, right? Both are same but in different meaning. So that means force is linear direction, torque means angular direction. So resistance to acceleration is inertia, resistance to angular acceleration is moment of inertia. So the formula for moment of inertia is equal to I is equal to m r square divided by 2. So this is the formula we used in this experiment. I is equal to mr square by 2. M is the mass of the circular disc and r is the radius of the circular disc, right? This is the mass we are applying, so that I is equal to mr square by 2, right? Next one is define torsional pendulum. So if, the viva question is like this: define torsional pendulum. Already we know what is the torsional pendulum setup. The one rigid clamp, in that one thin wire is there, which is attached with the one end of the thin wire. The circular disc is suspended. Two chuck nuts will be there. So this is the torsional pendulum. So now what we are doing, we are twisting this. That means we are making the angular acceleration in the circular disc. It is trying to twist the wire. After that it will be released. So again it will try to come back to the original position, but it cannot. So it will be twisted and released. So what is happening now? That oscillation will be produced in this case. The mass will oscillate back and forth now. Right? This is what happening. So this is called torsional pendulum. So now listen, a torsional pendulum or torsional oscillator also we can say consists of a disc-like mass suspended from a thin rod or wire. In our experiment we are using wire only. When the mass is twisted about the axis of the wire, listen carefully, this is the axis of the wire, about that the mass is twisted. The wire exerts a torque on the mass. Okay, now torque is produced, tending to rotate it back to its original position. So it will try to come back to the original position. But what is happening? If twisted and released, the mass will oscillate back and forth. Okay, executing simple harmonic motion. So this is the angular version of the bouncing mass hanging from a spring. So this is the spring in with one bouncing ball is attached. So how it will move up and down? Okay, like that it is the angular direction it is taking place. So this gives us an idea of moment of inertia. So if anybody is asking what is the basic principle behind this experiment, means you have to say angular simple harmonic motion. Okay, angular simple harmonic motion. So here I discussed some viva questions about this experiment. If you have any doubt regarding this, you can ask me in the comment box. Thank you everyone.